Hi, in this video I'm going to go through question 1 part F on the Mat 2009 paper. So for this question we want to know, when does this quartic have 4 real solutions? Okay, so let's think about what the graph of this is going to look like. So here is the graph of a general quartic, and we can see for this to have solutions, I'm going to want one of the minimum points to be below the x-axis. And if we wanted 4 solutions, then I'm going to need both of these minimum points to be below the x-axis, but also I want the maximum point to be above the x-axis, because if it looked like this, then now we've only got 2 solutions. So we need this graph to be like this in order to get our 4 solutions. So let's figure out where the minima and maximum of our quartic are. So if I set y equal to our quartic and differentiate, we'll have this, and now we can just set this equal to 0 to find the stationary points. So if I put the derivative to 0, and then we can factorize this cubic into 12x times x minus 1 times x minus 3. And so we see that our values of x for when we have stationary points are 0, 1, and 3. And just by the shape of the graph, we can see that our minima are going to be at when x is 0 and 3, and x equals 1 is going to be our maximum, because it's the middle stationary point. Okay, so let's work out our y values at our stationary points. So when x is 0, then we see putting 0 into here, we just get k. And when x is 1, then we get 3 minus 16 plus 18, which is 5 plus k. And then for when x is 3, because I didn't want to multiply out these large powers of 3, first I factorized out 3 cubes from everything, so I got 3 squared left from this term, then minus 16 from the second one, and because 18 is 6 times 3, then I was left with 6 from here. So this here inside the brackets is just minus 1, so I got minus 27 plus k. So because we know that to x equals 0, this is a minimum, and for x equals 1, this is a maximum, and this is also a minimum. And for 4 solutions, we want both of the minima to be below the x-axis, i.e. less than 0, and we want the maximum to be greater than 0. Then we see what we get is that we need k to be less than 0, 5 plus k to be greater than 0, and minus 27 plus k to be less than 0. And so if I label these inequalities 1, 2, and 3, then we see the conditions we get for x are that it must be less than 0, greater than minus 5, and less than 27. Well, if it needs to be less than 0, then it's obviously less than 27, so this condition is actually kind of irrelevant. So if we need k to be less than 0 and greater than minus 5, then that's answer D.